Hey guys, once again we are going to record a video. This is a video for financial risk management guys, and what I want to do, I want to show you confidence intervals and hypothesis testing in action. Okay, so we're talking about confidence intervals and hypothesis testing. So remember, right, we ran in class, we ran basically a regression of a stock, which is ExxonMobil, right? We actually ran it against the SPY index and the oil, okay? And you can see here that 0.84, right, is a coordinate for SPY, and 0.16 is a coefficient for US oil, okay? And then you have also an intercept, which is 0.01001386, so it's very small, right? And we said in class that Y, right, this is ExxonMobil, is going to be, what it is going to be? It's going to be basically, you know, the intercept, which is 0.0001386 plus 0.84 times SPY plus 0.16 times ExxonMobil. Okay. Now what we want to do now, we want to look at the coefficients, right? What we want to do is to look at the coefficients and investigate their distribution. We said that these guys are normal variables, right? And we said in class that we have a covariance matrix, but because we are simple people, we're thinking one-dimensional, we're just going to concentrate on the diagonal elements, okay? We're going to take standard deviation, right, the square root of these guys, and we're going to get, okay, the standard deviations of those normal distributions, right? So once again, it's not, when you don't have too many observations, right, it's not going to be a normal distribution, but as the number of observations increases, by central limit theorem, the coefficients, right, you can assume that they are, approaching multivariable normal distribution given by the covariance matrix, right? And the diagonals, right, are the volatilities of those coefficients, okay? Now, if you have this, right, you can actually start constructing confidence intervals of those variables. What is going to be a confidence interval of 85%, for example? A confidence interval for 85%, okay, for the coefficient 0.84 is going to be basically an interval around 0.84, such that that if this is a distribution of your beta just as a standalone, right, this guy is going to be 95% probability. So if you throw a coin with a distribution given by this beta, in other words, an average of 0.84 and volatility that you can see there of 0.015, right? This is going to be your 95% interval, okay? And you can see there that Excel shows it to you. So in column F, here, those guys and those guys, right? This gives you, okay, the confidence intervals. So the upper confidence interval is 0.87. The lower confidence interval for 0.84 is 0.81, right? And you can say that with probability of 95%, you have basically these guys, 0.81, 0.80, what was it, 0.84, and this is 0.87, and this is 0.81, and 95% probability that your beta, right, is going to be in this range. So what does it mean? It means that keeping x constant, okay, you are going to simulate your y through the normal random through the normal random variable, okay, through this residuals. You're basically concentrating just on the residuals, okay? You're going to get a new y, a new set of y's, right? And when you're going to run the regression, okay, you're going to land, your beta estimates is going to land in this, in this range, okay? That's how you can think about that, right? Now, where does hypothesis testing comes in? What you want to do in a regression, you want to verify that with a high probability, your betas are not zero. Because if your betas are zero, right, then basically you have a problem. So your hypothesis testing, in this case, your null hypothesis, will be, for example, that beta SPY equals 0, and your alternative hypothesis, right, that beta SPY is not 0. Okay? And then you choose a threshold. You choose a threshold of 95 percentile, right? And you can see here, right, that the 95 percentile threshold, 0 is not part of this interval, okay? 0 is nowhere near between 0.81 to 0.87. Okay, so you reject the null hypothesis. You take your alternative, and with very high confidence, you can assume that beta is not 0. Now, whether or not beta, the expected beta is actually 0.84 is a different question. Okay, the question that we're concentrating now on, right, whether you are actually having some non-trivial contribution, right, from this factor, from the SPY. And indeed, if you think about the CAPM, that's what you would like to expect, right? In the CAPM world, okay, mu of the market times R, right, times beta, right, equals to basically, mu stock minus R. Okay, this is a one-factor regression. Here you add another one, right, which is your beta 1 plus beta 2 oil. Okay. And these two guys together predict long-term, right, the behavior of the equity of this ExxonMobil, right? So that's kind of the crux. And you can see that the fact that the beta is not 0, actually it kind of give you confidence that the market does have some impact with the oil. Okay? Now, what about the intercept? If you look on the CAPM, right? If you look on the CAPM, you want the alpha, the intercept, to be 0. And once again, think about, the CAPM story, right? The CAPM story, or any factor model story, okay, will tell you that longer term, everything is determined by the factors, and you cannot create, right? You cannot create anything outside those factors, okay? If you are going to create something else, then it will be your alpha. So it will be different, right? So now, let's assume now we are going to test our hypothesis for the alpha, okay, for the intercept. And if you look on the intercept here, okay, you will see that the confidence of the intercept is minus 0.0002 32 and 2, and it goes to 0.000005, right? Something like that. Okay, so Excel is gone. It's okay. I think you got the idea with this, so I'm going now to do it here. Okay? So now you're asking yourself, gee, if I have my H equals 0, right? My H0, which is a null hypothesis that alpha equals 0, versus H1 that alpha is not 0. Okay? Can I reject or can I accept this hypothesis, right, if I'm looking on this? So you see that in the 95 percentile, right, with the 95 percentile, you can see here that that 0 is inside. Because 0 is between minus 0.00232 and 0.00005, right? So in this case, you will have no choice but to accept that alpha equals 0. Okay? Now, there is something that, now the interesting question is here is as follows. Say you have basically your expected value, which is here, right? This is your alpha that you got, or beta, or whatever that you got from. And then you have this distribution. Where does the 0 lies, right? What is the probability? What is the probability that if you are here, it will reach 0 or left to it, right? And how do you do that, right? Think about how you do it, right? So you want to standardize. So you have basically your, your expected value, which is mu, which is your alpha, right? And then you have sigma alpha, which is a standard deviation of alpha. For intercept, for any of the coefficients, right? You have beta I, and you have basically, the sigma of beta I, okay? And now what you're doing, right? You want to standardize. So what you're saying, you're looking on 0 minus alpha divided by sigma alpha. And you get a number here. I don't know how to say, let's call this number P alpha. Okay? You get a number here which is P alpha. And here, right, you're getting the same way, in the same way you're getting beta I minus sigma beta I, you're getting 0 minus beta I divided by sigma beta I, right? Which is basically minus beta I divided by sigma beta I, and let's call it P beta I. So now what you want to do, you're looking on your standard distribution. This is now your standard, right? Because you standardize your distribution, right? This is your standard distribution with 0, 1. Right? This is a standard distribution with 0, 1. And somewhere here, you have your P alpha, right? So the probability of being left of the P alpha, right? This is called your P value. So if you look on Excel, the P value there is 46%. Right? So it means that for the intercept, right, your threshold here and to the left is going to be at like 40%. So it means that if you throw a coin, right, the intercept can be actually 0 or outside this range. Okay? Of course, looking on points, right, it doesn't make any sense because we're like measure 0 in a measure 0 situation. But when you look here on something like that, you can start thinking, oh my God, I have an event which is 0, or maybe it's even negative. Negative intercepts do not, they don't make too much sense, right? Because you want the intercept to be positive. If you invest, right, and you invest in a portfolio of betas, and suddenly your intercept is negative, then it's kind of a bad sign because you basically says that on a long term you can actually lose money if you invest against the factors, right? It's little. I mean, you can have those kind of things, but that's kind of those kind of stocks are somewhat unusual, right? So in this particular case, your P value is going to be basically the probability of being, outside this range. So now people like to have P values to cut it here and also to cut it on the other side, where instead of 0, they would put 2 beta I, right? So that's what they call P value. And that's what you have in Excel. So if you take the, Excel P value, which for this one was, I think, 46% or something, right? And you divide by 2, so it's 23%. So you will see that in this particular case, you're going to have 23%, this distribution is going, the alpha, the intercept is going to be, the probability of it to being 0 or negative, right, is around 23%. And probability of it being on the other side of the, the equation is also 23%. All right? So I think this, I hope, this clarifies how, hypothesis testing is done, right? So hypothesis testing is basically testing for confidence intervals in disguise. What you want to do in hypothesis testing, you want to basically measure some, check some range, right? A threshold. You want to choose your threshold, okay? And based on this threshold, you want to either reject or accept the hypothesis. Now, if you have a null hypothesis, for example, right, and you have an alternative which is basically saying that something is not zero, you can choose, the confidence interval. You can check the confidence interval. If zero is there, you will not be able to reject the null hypothesis. If zero is not there, right, you can actually reject the null hypothesis, and you can actually accept the alternative hypothesis that beta is not zero up to this threshold, right? So if the threshold was 100%, right, you will never, ever, ever be able to accept any hypothesis. Because if the threshold is 100%, it includes all of them, so it means that beta can be anything, right? We're talking about situations where intercept or betas, right, cannot be such numbers with a very small probability. Can be such numbers with a very small probability. For example, in this case, we're talking about zero. Okay? So I hope that you enjoyed this video. It had basically an Excel component to it. I wanted to show you, where you can see those things in Excel. But one thing I want you to remember, right? I want you to remember that Excel constructs only one-dimensional, confidence intervals. So only on the diagonal, right? So if we want to create confidence intervals for more coefficients, for example, if we want to test whether beta 1, beta 2, and beta 3 simultaneously are zero, right? We need to go to the multidimensional case, okay? And there we have to, deploy some other methodologies in order to kind of measure our confidence intervals. It's possible. It's possible. Everything's possible, but it's a totally different ballgame. So hopefully you enjoyed this video, and we'll continue working on this in class. So the next thing that we're going to talk about is going to be stress testing. So I'm going to show you, right, how from those regressions you can actually go to stress testing very quickly. All right? So great teaching you. I really enjoy, discussions in class, and I hope that you enjoy enjoy me as I enjoy you. Okay? Thank you very much, and have a great weekend.